So for problem 97, technically it is part of the homework. However, my experience is that helping students with this problem in class is much more helpful than sending you home with them. This is actually a really good example of how to solve a word problem that we then can use for our next lesson, where you are making your own poster based on the problem that you're assigned in your team, and then with a presentation with it. So 6-97 says, for the end of year party, Mount Rose Middle School ordered 112 pizzas. There were 8 fewer veggie pizzas than there were pepperoni pizzas. There are 3 times as many combo pizzas as pepperoni pizzas. Use the 5D process, nope, to define a variable and write an equation for the situation, then determine how many of each kind of pizza were ordered. So the first thing I need to know is I need to define my variable. Which one is going to be the key that helps unlock the other kinds of pizza? So we're going to look at how many times they're mentioned. And again, we're also going to look at those relationships there. So there was 8 fewer veggie pizzas than pepperoni. So veggie has been listed once, pepperoni also once. There's 3 times as many combo pizzas, just once, as pepperoni pizzas. Ooh, that's twice. So I think I know what my X is going to be. It's the key that unlocks the rest of them. Once I know what pepperoni is, I'm going to be like bam, bam, bam for the rest of them. Okay? So in this case, my X equals the number of pepperoni pizzas. Like I told the students in class, especially when I'm teaching the same lesson 5 times a day, I don't want to write pepperoni as many times as we're going to in this problem. So I just write pep, and I hope that you're okay with that, meaning pepperoni pizzas. So we have X is equal to the number of pepperoni pizzas. So we know that we have 3 types of pizzas in this problem. So we have pepperoni pizza, which is our X. We have another type of pizza, a third type of pizza, and then we have the total number of pizzas that were ordered. We know that this is total. So we have the combo pizzas and also the veggie pizzas. So if we're talking about the total number of pizzas that were ordered by the middle school for this end of year party, I'm going to be adding them, right? We have addition there because we're finding that total. So if I go back in, the end of year party, they ordered 112 pizzas. That sounds like my total to me. So I'm going to put 112 right there. Next, it says there's 8 fewer veggie pizzas than pepperoni. So I know that X is my pepperoni, and I have 8 right here, and it says 8 fewer. Does that sound like addition, subtraction, multiplication, or division? In this case, we're talking with less. It's going to be fewer. All those are words for subtraction. Oh, and that was supposed, oh, I put it in the wrong spot. Hot diggity dog. Let's fix that. X minus 8. That was my veggies. That probably would have been easier just to change my labels, but yeah. Sometimes I don't like to do it the easy way. So we need to figure out how many combos. So let's see here. We have 3 times as many combo pizzas as pepperoni. So that sounds like X times 3, or 3X. Okay, so now we have our equation written. We are now going to start with the first step, which is combining like terms. We're going to add the ones that look together. So right now I'm looking at X's. How many X's do I have? Hopefully you see 5X. We still have our 1s right here. We haven't messed with them yet. So now I'm going to isolate my variable. I want to make that x so lonely it can cry all by himself. So I need to get rid of whoever he's hanging out with. I need to make that a 0 pair right here. So to make that -8, 0, or the red top 8 red tiles to go away, I need to add the opposite, which is +8. And if I do that over here on the left of my equal sign or on mat A, I also have to do it over here for mat B. So I have 5x is equal to 120. But I don't want to know what 5x is. I want to know what 1x is, because that tells me how many pepperoni pizzas we have. So to make this a 1x, I need to make a giant 1. So I have 5 divided by 5. That makes a giant 1. If I'm dividing by 5 on the left, I need to do the same on the right to keep that equal relationship. So x is equal to whatever 120 divided by 5 is. Before you reach for your calculator, I'm going to kind of break it down a little bit. So what times 5 gives me just 100? Hopefully you said 20. If I have if I have $20 bills in my pocket and there's 5 of them, I got $100. Then I have 20 divided by 5. So what times 5 gives me 20? That is 4. So x is equal to 24. But it's not just 24 of anything. It's 24 pepperoni pizzas. And that's important because we need to go back in and figure out how many combos and how many veggie pizzas there were. So I'm going to let's start with veggie. So I have x minus 8 is for our veggies. So I'm going to put my 24 minus 8. And 24 minus 8 is 16. So we have 16 veggie pizzas. And then we have over here, we have 3x for combo. 3 times 24 is. So sometimes kids want to reach for a calculator here. But what I'm going to do is I'm going to halve this factor and double that one. So half of 24 is 12. Doubling 3, so 3 times 2 is 6. So what is 6 times 12? Hopefully you said 72. Now, this is where if I wanted to hold true to what we should do, we should take the 24 right here and we should put it in here and solve. I don't want to do all that work because we've already done quite a bit of that work already, because this matches this part and this matches that part. What I really need to do is see if I add 24 plus 72 plus 16, if that equals 112, right? Because that's what all of these numbers were. So if I do that, I'm going to add 24 plus 16 because I like that nice little 0 right there. So that means I'd still have 72. So, and then I would have a 0. I would carry. We end up with 40 there. Am I adding the wrong numbers together? No. Brain had a little short circuit there for a second. 7 plus 4 is 11. Plus, I can't forget about my ones place. Oh, good news. You were right. So again, for this problem 97, this is the one I referred to over and over again as we were making our posters in 6.2.5, because this has everything that you need to be successful, except for they rounded in that poster problem instead of actually finding the solution. But I'm going to go over that in a different video.